Hi there, my name is Gabriela Rakaseca, and I'm here today to give a tour of my completed website on the impact of scientific computing. By the end of the tour, you should be left with new or further knowledge on the concept of scientific computing. This here is the cover page, and is a pretty basic introduction to what the website has to offer. Now, I programmed this website about scientific computing through a website called cPanel. This website had allowed me to make my complete site as you see here. I use HTML to place all of my information onto each separate web page and CSS styling to customize the overall look of my web page. An example of this is how there's a white background behind all font on the web page, and there's a picture theme behind the following information. By the use of cPanel, I was able to make my website come to life. Now, you might be wondering, how did I go about choosing the images you see on this page? Well, first, I went to Google Images and found my background image that I would later on edit. I was able to edit this background image you see here through Pixlr. In simple terms, you could say Pixlr is a Photoshop site. I edited the background by using the sponge tool and the brightness tool to really make the green and blue colors pop. I also styled my logo through Pixlr by using layering techniques, brightness tools, and the sponge tool to saturate some color values. By far, the coolest thing I got to do with my images was to create the animation you see here. I got to use a GIF animator site, and it was a pretty simple website that gave awesome results. For example, I just had to upload 3 photo files, then set a duration timer, then zip bam boom, I ended up with the result you see here. Explanations aside, let's look at the table of contents. You see here that there's a purpose page, impact page, technical aspects page, relationship to data page, and a reference page. Now, first, we're going to go and look at the purpose of scientific computing. All right, so as you see here, the first thing, indicate the name of the innovation and provide a clear description of its intended purpose. So, the purpose of scientific computing was sort of like there's like like they're changing the ways that people are thinking. Like there's a new term coming out called computational thinking, and this is defining the ways to improve ourselves and technology at the same time. They literally want us to think just like machines. Now, in these photos, you can see 2 people working on scientific computing and some coding numbers. All right, looking at the impact of scientific computing. Explain a benefit and or harmful effect of the innovation. So, some benefits of scientific computing is that it improves our intellectual framework and helps solve complex math problems. It even helps major fields such as pharmaceuticals, biotechnology, chemicals, also government and university research centers. Now, we're going to go over here and we're going to explain the impact that the innovation has had on society, economy, and or culture. So, scientific computing produces new and innovative technology. It helps with so much. It allows a person to capture specific information, and it even filters out irrelevant information we don't even need. Isn't that so helpful? It's also the automation of abstraction. This means that it defines patterns, generalizes specific instances, and does parameterization. Now, looking at letter D, indicate one field other than computer science, which is innovation has impacted or has the potential to impact. Now, scientific computing has the potential of impacting how people think. And this is just so crazy that people are starting to think just like machines. And just thinking, like bringing back the term earlier, computational thinking, it allows us to think and gather a computational solution through the mental activity of formulating a problem. Now, right here is a video that I created with my friend, and we were having a great conversation about scientific computing. When you get the chance, you should definitely check it out. All right, looking at the technical aspects. Letter E, describe how a user interacts with scientific computing. A person interacts with scientific computing when using any and all forms of technology. The internet was created through scientific computing. I didn't even know that before I even looked up the information. Isn't that insanity? We use scientific computing in everyday life since our consumption of the internet is in constant usage. Like scientific computing is used in most communication, information, or even gaming technologies. It's what keeps us entertained in like the most simplest of ways. Letter F, describe in detail how scientific computing incorporates at least one of the big ideas of abstraction, algorithms, programming, and the internet to accomplish its purpose. So we're going to look at the internet. So the purpose of scientific computing is mostly through the internet because you need the internet to use mostly all technology. But let's get real here. And so it makes research simple and less complex looking than looking through a book. It more or less makes complex problems simple and easy to work with. And I don't know if you knew this, but the internet was formed through the creation of scientific computing. If scientific computing had not been invented, a lot of our technology we see would not have ever been possible. Now, these photos here are just some simple photos of some technology. Relationship to data. Letter G. Describe how the innovation consumes data as an input, produces data as an output, and or transforms data. So, scientific computing inputs codes to make up our data that we see online or basically anywhere. It takes these codes and produces information and programs that are useful to our general public. Then this transformation through the inflow and outflow of data makes up all forms of technology. We take this outflow and inflow and we make our technology through it. Now that is innovation. Letter D, H. Describe at least one data storage concern, data privacy concern, or data security concern related to the innovation. So, a data storage concern for scientific computing is on how to decide how far back we can keep information stored from. Scientific computing is an industry that is always finding new innovations, and keeping old information is more of a history lesson rather than a useful source of data. I personally don't know how far back one should store data, but it would make more sense to just document old storage methods and keep relevant data that is current and noteworthy. So as you can see here, is we have a graph, and it is on the impact of scientific computing on society versus on your own life. I collected the following data from a Google form that I created. I was able to give out this survey by posting the URL in a forum on Sakai. On the Google form was a quick and easy survey for my classmates to check the impact of scientific computing on their own life, which is the red bars, and the impact on society, which is represented by the blue bars. It was very accessible for my classmates, but not many took it. This made my amount of data to work with small, since it's a survey of, at most, 7 students. According to the overall results, these 7 students believe that scientific computing has triple the impact on society rather than their own lives. See here, literally almost triple this. That's absolutely insane that scientific computing has more of an impact on society rather than our own lives, even though we use it every day. All right, now we're going to look at the references. So as you can see, we have links here that we can click on and go to a site. So first, let's click on this link here and see what comes up. As you can see, this here is a Wikipedia page describing scientific computing. This website was very useful in helping me gather information, and I highly would recommend it. I feel this way because it's not only a website on scientific computing, it also has other related links within the reading. See here, we have algorithms, computer information science, computer simulation, and computation. But for now, we're just going to go and click on algorithms. As you can see, we have another site that's a smaller concept within the broader concept, which is scientific computing. Now, this is helpful because I can go and look at scientific computing, but also the other concepts within it. And I get brought to this separate page, and it focuses on the numerical process of algorithms and how it ties back to scientific computing and not just how it's a concept of it. The site makes it so that you can hit all the stops when learning about scientific computing.